So, today we're dealing with this kind of out of order before we do the trig functions, before we do the exponential and logarithmic functions, because frankly those ones are just memorization, unless you have composite functions, okay? You're going to just memorize the derivative of sine is cosine, the derivative of cosine is negative sine. There's not a whole lot to that. Until you get into things like, hey, what's the derivative of sine squared of 3x squared minus 5x? And now you've got a function inside the sine function, which is inside the squared function. And now we have a bit of a mess on our hands that we have to deal with, okay? Well, that kind of a composite function is what we're going to learn how to deal with today, okay? We're going to start getting the idea of this today, and we'll do more of this tomorrow as well. So, to deal with composite functions, we're going to be using something called the chain rule, all right? So what the chain rule is dealing with is this idea of we have g of f of x. We have this function that's inside another function. We often will just use a u to represent that inner function, okay? But the derivative of that is going to be the derivative of this g, the outer function. But notice we're going to leave the inside function alone. We're going to leave it as an f of x. So we're taking the derivative of the outside function, leaving the inside function alone, but then we're going to multiply that by the derivative of the inside function. Okay? Another way of thinking of this, and this is why we'll often use u here, is in order to get dy dx, you're going to take the derivative of y with respect to u. That's what we mean by leaving that inside alone. And then multiply it by the derivative of the inside with respect to x. And of course, if you did this multiplication, the du's cancel out and you've got dy dx. Okay? So the basic idea here is we've got the derivative of the outer times the derivative of the inner function. Alright? Now, I want to illustrate this, and then we'll do some practice with it as well. Alright, so as an example, let's say that I have the square root, well, let me make it that y equals the square root of x cubed minus 5x squared. Okay? Now, obviously you can see the composite nature of the function here. So we need to consider two things. We need to consider what the outer function is and also what the inner function is. Now sometimes the inner function can be a little bit easier to understand or to recognize. What is the inner function in this case? Yeah, it's that cubic polynomial there, x cubed minus 5x squared. So we'll call that u. Alright, so u is x cubed minus 5x squared. Okay? Now, taking the derivative of that is pretty easy. So I'm going to take the derivative of u with respect to x. And based on the rules that we learned yesterday, what would our du dx equal?
3x squared minus 10x.
3x squared minus 10x. Very good. Okay, so there we go. There's the derivative of the inner function. So that's part of what we need to find the derivative of y. Okay, but here's the outer part. Okay, what's the outermost function?
Square root.
The square root, okay? If to determine outermost, one thing that can be helpful is to say, okay, if I plugged something in for x and did the arithmetic, what would I do last? Okay, if I plugged in like a 5 for x, I'd cube it and then do the subtraction, blah blah blah. At the very end, I would take the square root. Okay, that is my outermost function, is that square root. All right, now, what you can think of here is that it's just the square root of something. Okay? And the square root of something is the same thing as something to the 1/2. Okay? So what's the derivative of something to the 1/2?
1/2 something.
1/2 something.
To the negative 1/2 power.
Yeah.
Do we not use like a variable or something to represent?
Well, that's why we use u. Okay? Because we actually would rewrite this as the square root of u, which is u to the 1/2. And that gives us a derivative that is 1/2 u to the negative 1/2. Okay? But notice here, whether you're using the word something or whether you're using u, that u stays the same throughout this entire thing. Okay? And in the end, the derivative of the outer, that 1/2 times u to the negative 1/2, or we could simplify that to 1/2 square root of u. I don't want u's in my final answer. I want to have it in terms of x. So this is where I got to remember, okay, what was u? U is x cubed minus a 5x squared. Okay? And now I have the different parts that I need, okay? Because what I just found was the derivative of the function with respect to the inner function. That just means I leave the inner function alone. Okay? So now, to do dy dx, according to our chain rule, I got to do dy du times du dx. So the two parts that we just found, we are now going to multiply together. Dy du is 1/2 square root of x cubed minus 5x squared. Du dx is 3x squared minus 10x. And of course I can simplify that just by writing it as one fraction. 3x squared minus 10x over 2 times the square root of x cubed minus 5x squared. Okay? And that's it.
That's the answer?
That's the answer. Okay? We're going to leave it like that.
This is complicated.
It seems complicated, and when you first start doing it, you're writing down a whole lot more than you'll write down in the near future. Okay? In the very near future, we're going to look at this, maybe rewrite it once, and then write down our answer. Okay?
Can you just explain like the dy over d, like what does that mean when you're doing dy over du compared to du over dx? Yeah, I was about to ask that question.
Okay. So dy, y is the function itself. Y is the square root of something.
So you're taking the derivative of y.
Yes.
Uh-huh.
But I'm taking it with respect to u here.
But you're not changing u.
I'm not changing u. I'm leaving, notice here, u stays the same. Just like if I took the derivative of x squared, it's just 2x. The x stays an x. It doesn't change.
Okay.
Because I was taking the derivative with respect to x. If I take the derivative with respect to u, the u stays a u. I just happen to know that u equals something, so I plug it back in at the end.
Okay.
All right? Okay. Any questions?
Now do we do the practice?
Okay. Let's take a look. I'm going to ease you into the practice a little bit here. Okay.
Thank you.
So the first thing that I want to do here with this practice, wait, where are my lines? There we go. Okay, so first thing I want to do with this practice is I simply want you to identify what is the outer function and what is the inner function. Okay? In other words, the inner function would be the u. Okay?
For each one.
For each of these four. Yep. All right, so let's work through these. You'll notice I added a couple of extra things here on the side, but let's go ahead and work through. First of all, let's go ahead and get the inner function for each one. So what would u equal in A here?
3x plus 10.
Yeah, 3x plus 10. Okay, that's the inner function. How about on B?
2x plus 4.
Good, 2x plus 4. And on C?
X squared minus 3x.
Good. And D? Whoop.
3x minus x squared.
Yeah, 3x minus x squared. Okay? So that's the easy part there. We got the inner function. Okay, we've got our inner function. Now, the outer function, what is that for A?
U cubed.
Okay, it's something cubed, so u cubed. Alright, how about for B?
1 over u.
1 over u. Now, I don't know how to take the derivative of 1 over u, but how could I rewrite that?
You could rewrite it as u to the negative
Yeah.
1. U to the negative 1.
Yeah, u to the negative 1. Okay, so u to the negative 1 is how I'll rewrite that. So now I know I could take the derivative of that. How about for C? Square root of u. And in order to take the derivative, I would rewrite that as
U to the 1.
u to the 1/2. Okay? And then how about for D?
10 over u to the half negative 10.
Okay, 10 over u cubed, which would be what?
No,
Very good, Adam. 10
u.
u to the negative 3. Okay? Alright, so we've identified what we need to identify. At this point now, we need to actually start taking some derivatives. Okay? So, first of all, dy du, the derivative of u cubed is 3u squared. At this point, I'm going to plug u back in. Alright? So, I'm going to make that 3 times 3x plus 10 squared. Okay? So taking the derivative with respect to u, and then I'm plugging back in what u equals. How about the derivative of u to the negative 1?
Wait, derivative of u.
On b.
0. -1, 0.
Negative 1,
Negative 2.
u to the negative 2. There we go. Negative 1, u to the negative 2.
-1.
Okay. Now I know that something to the negative 2 power means that it's over that squared. Okay, that's the negative 2 power. So, and the u is 2x plus 4. So I'm going to plug that back in here. Okay. How about u to the 1/2? What's the derivative of u to the 1/2?
1/2 u to negative 1.
Okay. So now if I plug back in, something to the negative 1/2 is in the denominator, and that half is a square root. So it's 1 over 2 times the square root of u. And u is x squared minus 3x. Okay? And finally d, 10u to the negative 3.
Negative 30 u to the negative 4.
Yep, there we go. Negative 30 u to the negative 4. And again, I'm going to plug in u. So I have negative 30 over something to the 4th. And that's something that u is 3x minus x squared. Okay? Has everyone followed what we've done so far?
Yeah.
Okay? Alright, so now we got to do the du dx's. This is the really easy part because there's no substitution or anything. This is just the derivatives you've been working with. So what's the derivative of 3x plus 10? 3. Okay. The derivative of 2x plus 4? 2. The derivative of x squared minus 3x? 2x minus 3. And the derivative of 3x minus x squared?
3 minus 2x.
3 minus 2x. Okay? Derivative of 3x is 3. Derivative of minus x squared is a minus 2x. Okay? Notice here, guys, we're only on day 2, and you guys are already using those basic rules we learned yesterday without even really thinking too hard. Okay? So, there's a lot to remember, but we're going to use it so much it's going to be really easy to remember. Okay? So now, for dy dx, all we have to do is multiply dy du by du dx. There's our chain rule. Okay, so we've done all the work, now we just got to multiply these together. So 3 times 3x plus 10 squared is going to be 9 times 3x plus 10 squared. Okay? So the derivative of 3x plus 10 cubed is 9 times 3x plus 10 squared. And then here we have a 2 times negative 1 over 2x plus 4 squared. So I multiply those together and I get a negative 2 over 2x plus 4 squared. again, I multiply 2x minus 3 now by 1 over 2 times the square root of x squared minus 3x. So I'm just going to put that 2x minus 3 in the numerator over 2 times the square root of x squared minus 3x. And then finally, I have a 3 minus 2x times the negative 30 over 3x minus x squared to the fourth. So I'm just multiplying that together. So it's a negative 90 plus 60x all over 3x minus x squared to the fourth.
Isn't it negative 4? Oh no, it's just the 4 because it's on the bottom line.
Yeah, the negative is what put it into the denominator, okay? Now, some people on this one asked, well, can I just leave this as a negative 30 parentheses 3 minus 2x in the numerator? You can, okay? If you prefer, in your numerator, to make that a negative 30 times 3 minus 2x, because we know there's not going to be any like terms that we could combine here or anything like that, there's no other way we could simplify it. Leaving it factored out like this would be fine. Now, if you had this and then plus 5 times 7 plus 6x or something like that, all in the numerator, then I would want you to distribute and combine the like terms that you could. Alright, simplify that part. Okay? But depending on your context, it might be better to have it distributed or it might be better to have it factored. So I don't mind either way you do it on that. Okay? Alright, so that's the beginning of the chain rule. Tomorrow we're going to practice a lot more. And we're going to do even some where you might have a chain within a chain.
Right.
Alright? So, but that's why we're building on this.
Would that mean like a function inside a function inside a function?
Yes, for example, like the one that I had given you,
So
it's hard to do with just these guys because there's not a lot of variety of what we know how to do yet, but
like g of f of something.
yeah, like you could have sine squared of like a 2x plus 5. So the outermost function is the square, and inside the square is a sine of 2x plus 5. Well, there 2x plus 5 is inside the sine, so you have a function in a function in a function. So you have to use the chain rule twice. Okay? But we're building up to that, okay? We're building up to that. This is why I wanted to do chain rule first, after we learn the basic rules, because we're going to use chain rule with our trig functions on Thursday. We're going to use chain rule with our exponentials and logarithmic functions on Friday. Okay? We're going to be using chain rule over and over and over and over again. Okay? So, again, this is a rule that can be a little bit complicated, but once you get the hang of it, it really won't be that big of a deal. Okay? All right.